This time I will discuss the steps of designing doubly reinforced beam. Again, what is doubly reinforced beam? If the beam has reinforcement in the tension side and in the compression side, that is called doubly reinforced beam. So this time I will discuss what are the steps to design this beam. So step number 1, calculate load. Yes, whenever you design any member, beam, column, slab, whatever it is, you must calculate your load. Then step number 2, calculate factored moment mu. Based on your load, calculate your factored moment. Then step number 3, you have to think about singly reinforced beam or doubly reinforced beam. So this is a symbol, singly reinforced, that means reinforcement only in the tension side. Doubly reinforced beam, reinforcement in the tension side and in the compression side, both. So you have to think about it in step number 3. Now, when doubly reinforced beam may occur, I told you in my previous video, whenever there is a size restriction, that means your beam cannot exceed this width, this height, then and your load is huge, then your doubly reinforced beam occurs. Otherwise, if there is no size restriction and the load is small, then your beam may not be doubly reinforced beam. So you have to, if the size is given by architect or by your owner and your load is huge, then pay attention here. So how to find mathematically whether it is doubly or singly? Simple, calculate mu, whatever you found here, over P BD square. B is your width of the beam. If you forget what is B, B is this size is B and this size is D. D is from distance from compression phase to the tensile reinforcement is D. And phi assume 0.9 because we assume that our tension is still yields. So calculate this and find rho. Where can you find rho? In your book, in appendix, there are so many tables. Say appendix table A, if I can remember, A8 to A13. So then you can find your rho. If your rho is greater than rho max, that means whatever maximum rho you can provide, if your rho is greater than this, that means no, your beam is not singly, it is a doubly. Now what is rho max? Rho max is when your epsilon T becomes 0.005. So if we provide your rho greater than this value, then that means your still will not yield. So that is called rho max. Where you will find it? In your appendix, a table A7, you can find rho for which your epsilon T is 0.005. That is called, we call it rho max. Actually, it is not, theoretically, that is not rho max. But we assume rho max is the rho at which your tensile strain is 0.005. Okay. So if it is greater than this, then it is doubly. If it is smaller than the rho max, that means whatever reinforcement you need is less than the max. So it is singly. It is singly reinforcement beam. Now, if it is singly reinforced beam, what to do? Whatever you learn in your beam design, in a singly reinforced beam design, whatever you did earlier, that is good enough. If it is doubly, if this is your case, then what to do? This is our discussion today. Then we'll come to step number 4. If doubly reinforced beam, what to do? Select rho equal to rho max. That means whatever the rho max, whatever the rho will give me this strain, we will select it. We will select it. And where you will get it again, it is in table A7. That means in your appendix chapter. Okay, so we selected this. Then for this rho, we will find mu over P BD square from table. Which table? Table appendix A8 to A13. You will find this value. You will find this value. So based on your row, find this value. Once you find this, then find the moment, maximum moment this section can take. How to find it? This value times phi b d square. So this is the moment can be carried if you provide a maximum amount of reinforcement in that section. So now then, what is the excess moment? There will be excess moment. Why? Because your beam is doubly reinforced beam. And this portion is all about singly reinforced section. So there is an additional moment, that is mu, whatever moment you calculated here minus whatever it can carry by providing the maximum. Whatever is left over, then you have to provide extra reinforcement for that. That is step number 7. Additional reinforcement to carry this extra moment. So whatever moment is left over, to carry this moment, I need to provide some extra reinforcement, AS2. How much? This. So this moment is here, Fy d minus d prime. You know what is d prime? D prime is distance from here to here. That is called d prime. Okay, so I will erase some space here. So carry this, right here mu to make it simple. I made some space here to look beautiful. Okay, then step number 8. So we found our AS2. AS2 means whatever extra reinforcement I need in this side. So you can see in the tension zone I have two reinforcement, AS1, AS2. What is AS1? The maximum I can provide. Did I write somewhere here? I did not write it here. AS means whatever I row selected here, my AS1 will be rho max BD. That will be our AS1. Whatever reinforcement I provided here, that is AS1. Whatever I need extra, that is AS2. That is for extra moment. Okay, now we will go to the other side. This reinforcement. How to calculate AS prime. That is our story here. Step number 8. Lot of steps. 8a, find A. AS1 Fy over 0.85 F prime C B. In my previous video, I discussed that there is some limitation here. Which is we assumed Fs prime is Fy. So there is some limitation. Still though we use this because it gives us very close answer. We do not need any fine tune. But if you want, you can. That is a different discussion. But this is good enough for designing. Okay, so we will find A, then beta 1. You know what is beta 1. Then C is A over beta 1. Then strain in your this concrete. Strain in your compression steel. Sorry, not concrete, steel. Strain in your compression steel. E epsilon S prime. C minus D dash over C times 0.003. In my previous video, I showed how to find it. It's very simple. It's all about the strain diagram here. I'm not going there to make it complex. Okay. So you saw that equation in my previous video. How can we do this? Then what is my yield strain? What is the yield strain of the steel I am using? Yield strain is yield stress divided by modulus of elasticity. We know this equation from our strength of material class. Strain equals stress over modulus of elasticity. So yield is Y means yield. Yield strain is yield stress divided by modulus of elasticity. What is your yield stress? Whatever material you are using. If you are using 60 grade steel, your yield stress is 60,000 psi. If your steel is 40 grade, then yield stress is 40,000 psi. What is your modulus of elasticity? For steel for steel material, it is always 29,000 KSI. So this value is known. Now whatever you calculated here, you have to compare it with this, whatever you found here. If your strain is greater than or equal or greater than this, that means your AS prime, your reinforcement here yields. So if your calculated strain is greater than or equal to this, then your AS prime yields. If yields means what? That means whatever you can use here FY. Whatever the stress you need here, you can use FY. If your calculated strain is less than is less than this, that means AS is not yielding. In that case, how can you find your stress in this concrete? Simply strain times modulus of elasticity. Same equation here. So then you have to calculate your stress in this steel by using this equation. Now whatever you found, either this one or this one, you can then calculate your amount of reinforcement using this equation. AS to FY divided by FS prime. If it yields, then you will write here FY. If I cancel, these two reinforcement will be equal. So if it yields, your life will be easier. If it doesn't yield, your life will not be difficult. Just you have to calculate your stress. Once you calculate your stress, then find your amount of reinforcement. Then what is our total reinforcement here? AS1 plus AS2. What is the reinforcement here? AS prime. Okay, then step number 9 is that. Then step number 10, detailing and 6. Then you will detail. What is detail? What will be your number of bar and their spacing? What will be the number of bar here and their spacing? Then show the clear cover, check the minimum spacing between bars. Whatever detailing you learned in your previous classes, and also show your design in a very big and neat sketches, so that even a field labor can read your sketch. So do not make your sketch so small, bigger and clean. And that is like detailing and 6. So hopefully you understood the design steps of doubly reinforced beam. Whenever you see a beam design problem, if the size is given, then this might be a doubly reinforced beam. So you have to check here. Is number 3. If the size is not given, size means the size of the beam is not given, the beam is never doubly reinforced beam. So whenever the size of the beam is given, pay a special attention, so that it can be a doubly reinforced beam. If it is a doubly reinforced beam, no scary, just follow step 1 to step 10. Then your life will be easy. Okay, so in the next video, what I will do, I will solve or I will design a doubly reinforced beam to clarify these steps. See you then.